Hey everyone, what we're going to do today is look at converting equations, and we're going to go two directions eventually, probably one in this video, one in another video, but going from polar to rectangular and rectangular to polar. We've done it for coordinates, but this time we'll be doing it for equations. Just as a reminder, I'm going to write these up down here. We have, these equations, x is our cosine theta, and y is our sine theta. And then we also have the tangent, Tangent theta is y over x. And we also have the Pythagorean, x squared plus y squared is r squared. So those are all based off just the same triangle written with polar labels and rectangular labels, but those are how our polar and rectangular, both coordinates and equations, are going to relate to each other. So right now we have kind of these three that are listed here. We'll start with the y is x squared. This is going to be sort of the easier direction to go in, because a lot of times for these you'll again just kind of plug in for the x and y, that r cosine theta, r sine theta. You might have to do a little bit of work after that to get it into r equals, but this is generally what you want to do. So we're going to have y is x squared, So we're going to replace that y, converting this rectangular equation to polar form. So replace the y. We got r sine theta going in for our y. Replace the x. So we got r cosine theta going in for the x. And all of that is squared because the x is squared. And then we want to simplify it, So this is kind of already in polar form. Generally, though, you're going to want to simplify this down a little bit, down to an r equals, because that is how most, at least graphing utilities, like to see it, is with r equals rather than in this type of form. Sort of like you usually want y equals for rectangular equations. So let's go and do that. So we're going to square the right side. So we got r sine theta on the left. We'll go and square the right side. So this is going to be r squared times cosine squared theta. And then we can divide both sides by an r, So an r on the left and r on the right will kind of divide out. And then we can also divide by a cosine squared, So we'll say this sine squared, or sine theta, not squared, over cosine squared theta. That would leave me with an r on this right side. And that would be it. So this would be a perfectly fine answer for changing that parabola into this r equals equation. Now with this, we'll go ahead and make a little comment here. Sometimes there are, you'll get to an answer like this and you'll check the back of the book and they'll have something else. Just because they have something else doesn't mean it's what you have is wrong. It could just be it's, in a different form. So sometimes they'll do stuff like this where they say, all right, I can maybe simplify this a little bit more by getting rid of the fraction. And I could do that by saying this is a sine theta over cosine theta times a 1 over cosine theta. That equals my r. So this is kind of like the identities, I'm just modifying this left side that I have over here. And sine over cosine is the same as tangent. So we got tangent theta. 1 over cosine is the same as secant. So this side I got secant theta. And this equals r. So that would also be a valid answer and something you might see in the back of a textbook. Now, which one should you use? It really doesn't matter to me. But sometimes, people like to use sine and cosines more, in which case the first one's good. Sometimes people like to avoid fractions, in which case the second one's good. So it just kind of depends on your purposes. If I were needing to do more stuff with this, like in calculus, then again, it might depend on what I'm going to do. I might want that second one over the first one. But for us, where we're just converting equations to graph, then either one of these is going to be okay. We'll go ahead and look at graphing these in Desmos at the end of the video. This is one way just to check that you're correct, right? This should look like this parabola, y is x squared. So we'll go ahead and do that, like I said, kind of at the end. Let's go ahead and do part B here, right? So part B, I'm going to go ahead and change colors real quick. We'll try this blue. So we got this x squared plus y squared is 9. Don't forget we have this equation right here, right, which is, actually, I think I got to change it there. Let's try that. There we go. So x squared plus y squared is r squared, right? I can replace, rather than just replacing the individual x and y, I can replace that entire x squared plus y squared with an r squared, right? So I would get r squared equals 9. Now it'll still work out if you go the other way to replace the x, replace the y, go through, simplifying, but it takes a little bit longer if you just recognize, oh, that r squared is the same as x squared plus y squared, then that can save you sometimes a little bit of time if it's in your equation. It's not always there, but when it is, works out good. Now again, we want to simplify down to r, right? So we're going to take the square root of both sides and say r is plus or minus square root of 9, which is 3. And usually there's one extra step that will happen on this one. So if we think about the equation r is 3, right, what would that look like? Well, the theta can be anything around the unit circle, any angle, but I'm always going to move out 3, right? So I'm always going to go 1, 2, 3, put a point, 1, 2, 3, put a point, 1, 2, 3, put a point. And we'll just end up basically with the circle radius 3 as we go around. So if I do r is negative 3, again, with my angle, I'm just going to go the opposite direction 3 units, but I'll still end up on this circle. So both r is 3 and r is negative 3 would give me the same circle. So usually they'll just say that's kind of redundant, so we'll just modify it then to just r equals 3. And this would usually be the equation that you would see in polar rather than both of them, because they do kind of copy each other. So this x squared plus y squared is 9, right? This is one of your conic sections, circle, radius 3. And then polar, same deal, just r is 3. Let's go and do the last one here. So we got y is 2x plus 1. And for this one, I'm going to go ahead and do the same thing we did on the first one, right? So we're converting to polar. Let's go ahead and replace both the x and the y there. So we got y, r sine theta, and the x, so we'll get 2 times the x, which is r cosine theta. Once I get that, right, I need to put in the plus 1, and then I can go ahead and see what to do after that. Again, we want to, I shouldn't have that r equals, or that y equals right there. We're replacing that. All right, so we go ahead and do that. Once we have this, I need to get the r's together. So I'm going to try to get both of these r's on the left side just by subtracting that 2r cosine theta. So we'll say this is going to be r sine theta minus 2r cosine theta, and then equals 1. All right. So that's what we get right there. Once I have that subtracted, right, I have an r in both of those, so I can go ahead and factor that out. So we'll say r factors out, and we got this sine theta minus 2 cosine theta left over equals 1. So again, here I'm just replacing, right, grouping the r's on one side, factoring the r out. Now I can get the r by itself just by dividing that by that big old parenthesis. So we'll divide, and we got 1 over the sine theta minus 2 cosine theta. Now in this one, right, we're just going to leave it like that. We're not really going to try to do any identities to simplify or do anything else. You can't split across subtraction in the denominator, so that's going to make anything that we try a little bit tricky. especially with that 2 there. So we're just going to call that good. All right. So that is just converting from polar or from rectangular into polar. Now, like I said, we can kind of graph these on Desmos to see if we're in the right ballpark, right? We kind of know what the rectangular equation looks like. We can graph the polar and kind of see what it looks like to see if we're correct. So I'll go ahead and pull up Desmos and then we'll take a look at that. All right, so here I have Desmos kind of pulled up and I already put this first equation in. So we have r is this sine theta over cosine squared theta. You'll notice down here it has this range, where you can change the kind of domain for theta. Right now I have 0 to 2 pi. That's going to be what you want for most things, although we'll talk about that more when we talk about polar graphs in the next section. But usually if you're not sure, 0 to 2 pi is good. Occasionally, if there's a different type of angle other than theta in the trig functions, like maybe a 2 theta or a 4 theta, things like that, then you might can adjust your theta there. But generally, if there's nothing special inside the parentheses, 0 to 2 pi is going to be good. Notice also if I go ahead and graph this r, right, equals, and I'm going to put in that tangent theta, secant theta. All right, so I got tangent theta, and let me go ahead and I really wish they had a theta button here, but anyway, tangent theta, right, and then we'll do secant theta next. So I'm just going to go to functions. You can also use trig functions here. So there's my secant, and then just type in theta. That is also going to be the same, right, same graph. So any of those, right, transformations that you want to do with kind of messing with the identities, changing some trig functions into another, right, that is something that you can do. Now notice this just says theta between 0 and pi, so Desmos kind of automatically picked that for me based on the functions I had. Well, like I said, we'll talk about the domains and restrictions and stuff like that a little bit more in the next video the next section when we talk about polar graphs and just how those are made and everything. But for now, we're just kind of converting back and forth. All right, so that is going to be that one. If we want to check some of the others, right, we could say that second one, right, r equals 3, right, that's an easy one. That's a circle radius 3. And, right, if I type that in, right, x squared plus y squared equals 9. Also circle radius 3, right, so I can kind of graph both of those and see, right, which ones I'm going to get. So circle radius 3 for both of those. The last one that we had was this y is 2x plus 1. So I'll go ahead and maybe hide a couple of these. And we'll graph that y equals 2x plus 1. So there's that line. And then I'm also going to graph r equals, all right, so r equals 1 over the sine theta minus 2 cosine theta. So I'm going to go and put that in. So we got sine theta, and might should just use that function there, theta. And then we'll go ahead and put in minus that 2 cosine theta. So minus 2, I'll just use the functions this time, cosine, and then theta. All right. And now you'll notice, again, it's kind of picking my domain for me. We'll go through that a little bit later, but you can see those do line up, right? So we are going to get that red line, that blue line kind of overlapping each other. One is in rectangular, one is in polar. Now I should mention in Desmos, if you're graphing polar, you do want to use r and then equals. And if you change it, like if you try to use subscripts like r1, then it's going to automatically put it back into kind of this rectangular. So it's thinking of this r as a y and this theta as an x, and graphing that equation right there. So you do have to use specifically just r, not r1, r2, any of that sort of stuff, just r by itself. So that's one thing to keep in mind. And a lot of times you do want to use theta. That's kind of what tells Desmos that you are graphing a polar equation, as if you're using specifically r and specifically theta. So just something to keep in mind as you're graphing those. All right, that'll do it till the next video. Next video we'll go the other way, converting from rectangular, or the other way, converting from polar into rectangular. All right, hope you guys enjoyed that one.